Today I'm gonna start doing the chapter 1. This is actually chapter 1 to maybe 3 together. It's an introduction part. I'm going to talk about several things. We'll talk about principles of computing. We are going to introduce assembly programming, C programming, some hardware interaction explanations, and some things that are related to our profession. At the end of towards the end of the semester, we will have invited speakers, and we will have projects, homeworks, midterm, and final, and probably quizzes as well. We will be going through Microsoft Teams for the class, which you already registered. If you haven't registered yet, please do so. Registration information is given on the department website. Exams are in class, plus there will be quizzes. Classes will be in class, so you have to come. But as you see, I will be recording the classes, including the screen. Therefore, if you want to go back to the class to study, I will be uploading them to some place for you to download. Okay. So when we go back, we will have history of science class, but I will have small, brief introduction about history of computers and how we come here. Computing goes back to 3,000 years ago, maybe more, but this is the only artifact that we can get. The abacus is the one that we have as the earliest artifact. Then starting 16th century, the slide rule until 1980. So around how much? 400 years. 400 years this slide rule was used. It is basically a ruler with moving parts on it. It uses the notion of addition. Addition is kind of logical. 5 plus 7 means 5 meters plus 7 meters. So if you move the ruler at 5 by 7 centimeters or millimeters, whatever, so the reaching point, the point that you reach, shows 12. Obviously, the computations are more complicated then, but addition is associated with movement. Linear movement is associated with addition. So by moving things on the slide rule, then we can do addition. But how about multiplication? Multiple additions? No. Remember, when you are taking logarithm, multiplications becomes addition. So if you multiply two numbers, the result is addition of logarithm of those numbers. So if you take the logarithm of those numbers and add them, the resulting inverse logarithm is the multiplication result. Did you know it? How many of you know it? Okay. So that logarithm principle goes back to I can't remember now. So helps us to make, because subtraction is moving backwards. Subtraction is moving backwards. So multiplication and division automatically can be converted to addition by the logarithm. So how do you take logarithm? That is the biggest importance of the slide rule. The ticks on the ruler, these ticks are arranged so that it shows logarithm values, such as it says 1, 10, 100, 1000, and so on. So if you slide that much, it means multiplying by 10, multiplying by 100. So from addition to multiplication and exponential representation, slide rule can be used. It is also used for trigonometry, so sine, cosine, etc., because those functions are plotted correctly on it. So if you move to the correct place and move the other one, the white thing, the resulting number in the other part of the, in the relevant part of the ruler shows the result. So it's basically translation through the logarithm principle at the base level. Then Charles Babbage, around 1830s, envisioned a computer. Couldn't make it, but envisioned. The first computation machine was built by Hollerith. I will show that later. It is the founder of the IBM. So it was the Hollerith company at the beginning. Then it's renamed as International Business Machines. First analog computer is computation. Computer is made in 1927, and then digital computers are started to be used around Second World War. So representation of quantities as digital was important. The invention of the transistor is done in 1947. Before transistor, there was vacuum tubes. Before vacuum tubes, there was relays. Before relays, there was mechanical switches, like Charles Babbage envisioned. So it was all mechanical. And after invention of the transistor, then integrated circuit is first integrated circuits, multiple transistors in one package, is done on one silicon chip, is done on 1950s, and starting that time, 1951 and 71 is the first microprocessor, Intel 4004. Then home computers, Apple II, IBM PC, and starting of the web. So that's how things moved. This is a video that you are supposed to watch by Richard Feynman. How many of you know who he is? Okay, good. Richard Feynman is a Nobel Prize physics scientist. He was one of the famous researchers, worked in Manhattan Project in the development of atomic bomb. How many of you went to the film Oppenheimer? Okay, good. I didn't. Did they mention Feynman in the film? Probably yes. I didn't watch. So Feynman is this guy. He has videos on his diet. He has videos on the web from his time. He is well known to explain things in simple manner, in simple language, and in a friendly way. He is from New York, I think Bronx or Brooklyn. Therefore, his accent is kind of interesting and nice. He talks very nice. So there is a video that he explains what a computer is in detail in a summer course in, I think, University of California, to the students that are coming in the summer session, special summer camp. His way of explaining things are quite interesting because he doesn't go formally, he doesn't go by book. He develops new way of explaining things, which is kind of simpler and understandable. It is a good practice for you to understand how things need to be explained differently so that the audience and the listener can understand better. The first thing in order to explain something good and nice is to understand you first in a good way. If you don't understand the topic, you cannot explain it. Anyway, so this will be the next week's homework and quiz topic. Probably. I haven't done it, so I will give the next week's homeworks tonight. This is an engineering school. We are in the faculty of engineering, and you are going to be engineers. So engineers, science, computer engineering, data science, systems engineering, programmer. These are the words that we use in our profession. So what are the differences? There are no differences. But when you say science, it means your father is rich or mother. Why? Because when you are doing science, money is not the object. When you are doing engineering, you have a boss, or worse, you are a boss. You have customers, you have time, you have money, you need to develop a product. So you are doing your best to solve the problem of the customer, to develop something. Maybe you are developing new things, the very innovative things, but there is a customer, there are people working with you, you are paying them, right? So there is a cost, there is time, there are computers in the lab which are capable of doing certain things, not much, the limitations. Therefore, engineering is hard. It has constraints. Constraints. When we say science, money is either given by the government or foundations, or you don't care, you are rich, so you are doing it yourself. You have no big expectations, there is no deadline. It may finish, it may not finish. It is like painting. However, it is important because it is the fundamental part. Someone has to do it. Therefore, in many countries in the United States, science, whether it is computer science or physics or mathematics or chemistry, is supported by the government. Because when government supports science, it is not related to direct to customer. It is the welfare of the nation as a whole. So it is long-term objective. But in the short term, you cannot eat rocks. Therefore, you have to make money, and then it turns to engineering. Then we have data scientist, systems engineering, programmer. These things are, but those are variations. They're all similar. The basic difference between science and engineering is, I think, the presence of the customer and doing science for the science, or improving the general knowledge in the field so that others can benefit, is the science. But if you are in a company and there is a customer and you are going to solve a problem, a particular problem or general problem, then it will be engineering. Engineering is, I think, stressful, difficult, and less often boring sometimes, because you need to repeat similar things from time to time. In the science, you don't care if a certain objective is achieved. You don't do it again because it is already done. But in engineering, you do it because you are making money. You have to. So the word, go back. The word engine what is that? It is a late word. When did they invent an engine? Around steam engine, 1800, the beginning of 1800. Before that, the word there, ingenuity. So it means a clever person, genius. So it comes from the genius. And basically, I searched for it. Engineer was the person even from the Roman times, in the medieval times. It was the person who was responsible from the arms in the army. So it was related to the army and army machines, like throwing stones, etc. All the things. That was the engineer kind of things, and mostly clever people were doing it. So it is related to engineers, genuity, etc. Comes from that. But after 1800s, the engine is found instead of horse, right? Then the word turned into engine. In some cultures, engineer is inferior to scientist. Scientist is like big guy. Engineer is the guy who starts and stops the machine. That happens. For example, in the ship, engineer is actually the third guy. There is a captain, there is a second captain, and then there is an engineer. So only responsible from the machines, starting and stop. So, for example, the engineer in the ship is not building a new ship or new engine. It means the guy who is responsible from the engine of the ship, operator. So it also has an operator meaning in some contexts, such as engineer of the train, engineer of the ship, engineer of the building. What? engineering of the building. So it means superintendent. It's like a technical person of the buildings, takes care of the air conditioning, etc. So all the it is also engineer, but we are not that. This human computer, this human computer video when we go back, the word computer is used to be used for this person. She was the computer. So, what is your job? I'm a computer. So that was the norm in 1950s, because computing was done by hand with those rulers and with the mathematics, with the pen and paper, and those were the computing people. So the computer room was the room of the computers, and that was the case, and it was mostly women. Therefore, that tradition continued even after the invention of the it is interesting for the girls here. Even after the invention of the digital computer, since the computing job is mostly coming from the girls in the past, new computers are also quite used by the girls until 1980s. After 1980s, I think partly because of the economy's growth and cultural changes, the woman is less and less interested in computing and computers. Then it became a man job in the 80s and 90s. Then today it is coming back again. So number of women in the computing and computer engineering is increasing again. Okay. One different thing between man and woman's brain is ability to represent problems sequentially by words is better in women. Therefore, for the men, they are better in drawing pictures and representing something pictorially, so spatially. But women are better to represent problems in sequentially, like a program. So a hypothesis says that programming is much easier for the women, but due to the social constraints, the women don't pay attention that much because it's a technical job. So we have less number of girls in engineering schools. This will be also, what was this actually? Düşürelim mi şeyini? Anyway, I will find a way to put it on. Bir daha. Bir daha. Okay, this film. Okay, here. Stop. This is the general image of the computer. We have the control unit. We have arithmetic logic unit, memory, some storage, and input and output devices. So, for the rest of your life, you will be dealing with this architecture. This is actually general computer architecture representation. Without any of these, we cannot say that there is a computer. So, in exams and in quizzes, this might be asked. So this film was watched last week by you. So did you like it? Probably yes. Let's move on. The URL is at the bottom. So let's start by explaining what an arithmetic logic unit is. Arithmetic logic unit is just like the slide rule. 5 plus 7 is 12. So I'm doing some calculation. As an electronic circuit, I want to add, subtract, multiply, do other things instead of slide rule or instead of hand. In the hand, how do I do it? When I say 21, so it means 21 sheep. 17 sheep. So 1 plus 7, 8. How do I know that there is 1 here and I say 3 plus 1, 4? So I was taught to make this computation. I don't count above, some of you do. I don't count above 21, which I can. If I start counting 17 on top of 21, that is also possible, right? But I don't do it manually. I developed a way in decimal system, ones, tens, hundreds, thousands, etc., in decimal system, so that I can do first digits. If there is a carry, I can move the carry to the next digit, and so on. So that is my style. That is my method. But it's a procedure, and it is done by the people. How am I going to do this with the machine? Well, Charles Babbage and Blaise Pascal, made some other inventors as well, mathematicians, made computations, additions, subtractions using dials. 5 plus 7, what it shows? 12. So they substituted rotation to incrementation. So they made a dial from 0 to 0 to 9, 0 to 9. So after one turn, if it still turns, the next one is affected, next one goes by 1. So it's like a clock. Do you know kilometer clocks in older cars, not non-digital cars, mechanical kilometer counters, they rotate. So if tens in ones in kilometer finishes, tens incremented by 1. If 10 is reached to the 9, 100 kilometers incremented by 1, right? So after 100,000 kilometers, what happens? You will have a new car because the kilometer goes back to 0. So that kind of addition, that's an addition, in the car works adding 1 by 1 kilometer as you drive. But you can make a machine so that that addition can be done with any number, right? So that will be a mechanical calculator. Have you seen, I have the picture, but have you seen any mechanical calculator in somewhere? When I was in your age, most government offices had one. The computations were done using those Devlet Malzeme Ofisi mechanical calculators. You rotate and press and rotate, change the digit, rotate like ones, tens, hundreds, 100, 200, 300, tick, 20, tick, 3, 123, 123. So by rotating and moving around the digits in decimal, they were able to add some. If in order to subtract, you rotate backwards. Okay, so addition and subtraction was possible. Also, there was a way of multiplication. How? Because multiplication means 5 times 6. You add 6 onto itself 5 times. 6, 6, 6, 6, 6, 6. That means 5 times 6. So that machine was able to do that too. There was a reverse counter for the multiplication. Multiplied by 5, multiplied by 1, multiplied by 3, 2, 3, 4, 5, 2 registers, then 6. So the counter shows the result because you added the other number 5 times onto each other. That was the older way. So rotation linked to the decimal system. With digital, no way. And also, this takes time. What we want is to get the answer immediately. Such as if I have this number and this number, as soon as I put these numbers, the electronic circuit should show me the result here immediately. How is it possible? With this logic, I can I can birader be. I can make an electric circuit like switches. If this switch is closed and this switch is closed, lamp is on. If this switch is off, lamp is off. So how long does it take? 0 time. If the electric goes, it is immediately known. So if I can make something using switches, electronic switches, on and off, etc., then I can get the result immediately. And actually, this problem can be translated into that way, because 1 plus 7 is always 8. I don't have to do it. It's a fact that 1 plus 7 is 8. So I can wire some complex wires and switches. If this switch, multiple switches, if this set of switches shows 1, if this set of switches shows 7, the light bulb 8 can be eliminated as an answer. So it can be wired to the result. Similarly, 2 plus 1 can be wired to eliminate the lamp at location 3 in decimal. But forget about decimal. Decimal is difficult, so people do it in binary. A binary number comes from here, another number comes from here, 4 digits, from 0 to 15 in decimal, meaning 0, 0, 0, 0 to 1, 1, 1, 1, 1. 0, 0, 0, 0 to 1, 1, 1, 1, 1. 0, 0, 0, 0 to 1, 1, 1, 1, 1. These switches are coming in. These switches are coming in either 5 volts or 0 volts, 12 volts or 0 volts, 220 volts or 0 volts, whatever signal you have. Water flowing, water not flowing, water pressure present, water pressure not present. So these are way of representation of the logic zeros and ones. And there are control signals like puppetry, add, subtract, rotate, add by 1, etc. So these are control signals that controls the behavior of this machine, the wires. So if I set something different, if I say 0, 1, 0 from here, it subtracts by 1. If I say 0, 1, 1 from here, the result will be a plus 1. This is the result. If I say 0, 0, 0, it adds. If I invert S0, it subtracts, because I changed the wiring. But the speed of this is actually the speed of light. Well, a little slower than that, because there are capacitors, transistors inside. So propagation is somewhat slower than the speed of light. Therefore, you have gigahertz, megahertz clock speeds on your devices. It is not light speed. It is lower than the light speed because of other reasons. So this is what we have, arithmetic logic unit, and it is present. It also is able to do AND, OR, NOT, and XOR. This is XOR. And the logic circuit of this is actually can be drawn like this. So this much complicated circuit, is it complicated? you are expected to say no. Yeah.
What does the buffer do?
There is no buffer here.
Okay, cool. So those are not. I can see from here.
These are not buffers. These are inverters.
I get it.
Not. So each of them, each gate can be implemented by 4, 5, 6 transistors. So each of them has 4, 5, 6 transistors. So basically we have, let's say, 40 gates here, or 50 gates, right? Around 50 gates. Multiply it by 5. So around 300, 350 transistors. You can make a 4-bit arithmetic logic unit. That kind of wires are, connections are necessary along with the transistors. Why do we need transistors? Because we need to switch on and off. I'm going to tell you. So that kind of complexity can make this happen. And when you provide signals here, 5, 6, whatever, the result immediately appears at the output. Immediately. No waiting, no computation. So some people say CPU is the brain of the computer, etc. It is very special. No, it is not very special. It is just a circuit. It is wired so that these control signals operate as expected. But we make it more complex and complex and complex and complex, but it is the same thing. And derivatives. We say it is kind of intelligent, American made, etc. No, it is just a circuit. Okay? There is no deep intelligence beyond this. It is just connections. So that is implemented by gates and or XOR, NAND, NOR, X, NOR. AND means there is a logic A and logic B. If there are 0, if any of them are 0, output is 0. If both of them are 1, it's 1. In the OR, either of them is 1, is fine. In the XOR, they have to be different. If they are the same, it fails. You also have inverted of. This is an inverted input, so it means X. This is the inverted output. So this is XOR. This is inverted output. Exactly the opposite of this. This means X. If they are the same, not going out. This is OR. This means not OR. This is the not. So the opposite of the above. This is AND and this is NAND. Making NAND and NOR gates are easier than making AND and OR gates. Actually, in order to make an AND gate, what people do is make a NAND gate and put an inverter in front in order to make an AND gate. In reality. Because transistor workings usually take the opposite of the input as they work. So in order to making NAND requires less transistors than making AND. But it is not relevant. People are not afraid of using additional gates. But in a good design, in a good logic design, minimalization of used transistors and gates is important. It's an optimization problem. Your chip is cheaper, it works faster, etc. but it is done by automation now. Who writes automation rule? Who developed by programs? Who writes automation for the logic? This is the sample transistor, small transistor, older type galvanium transistor. These are silicon, small power transistor, larger power transistor, more larger power transistor. There are bigger transistors as well, like my arm, for power applications. But these are the transistors. There are two types, PNP and NPN. What's a semiconductor? National Semiconductor, Fairchild Semiconductor, Intel Semiconductor. What is semiconductor? Why don't they full conductors but semiconductors? Any idea? You can speculate, make a joke, whatever. Huh? What's a semiconductor? You said something I couldn't understand. While semi means half, right? Semiconductor means half conductor. That means it conducts sometimes, but it doesn't conduct other times. So it conducts or doesn't conduct. So it is neither conductor nor isolator. Sometimes this, sometimes that. That's why we say semiconductor. And only two elements are possible to manufacture. One is the germanium element. The other one is silicon element. The electron from the chemistry class, remember, there was 2, 8, 8, 18, 32, right? Electron orbit numbers. Then after that, again 32. I think that. So silicon and germanium are in the periodic table. It has a special position. They have interesting number of electrons, I think like 2889 or something. They can take electrons from outside and they become conductor. If they have one electron more, it becomes conductor. If they give electron, it becomes isolator. So you can control their conductivity by adding additional impurities, like some aluminum atoms nearby, so that more electrons are provided nearby. So if you provide additional aluminum atoms, it becomes N. If you provide additional, I'm just making it up, copper, not copper, arsenide atoms, it becomes the other way, isolator. So you can change the behavior of silicon by injecting additional atoms. So they are either p-type or n-type. And they are isolator. But when you combine P and P, so this has less number of electrons. This has less number of electrons. This has more number of electrons. This becomes not conductor in steady state. In order to make it conductor, you need to equalize the amount of orbital electrons. I don't know the details, but you need to suck out some electrons from the n-type, suck out some electrons from that area to turn this into p temporarily. Then it becomes conductor. So I mean you can open and close, turn on and off by controlling some current coming into the middle section. If it is NPN, you inject some electrons, little bit inject electrons, so that it becomes NNN, and conductor. So it is basically related to the orbit issue and combining three different types of silicon semiconductors on the same chip, meaning that some of them are aluminum, some of them are arsenide, doped in the oven. They put silicon in the oven. Siz börek yapıyorsunuz şeyde, fırında. They put silicon in the oven and arsenide or aluminum solution in the next cup. At some temperature they wait and aluminum evaporates and deposits onto silicon. Okay, so it becomes N. Then they take them out, clean, put a protective film on aluminum parts, but open some other parts, put the oven again, this time put something different in the cup. That something different in the cup evaporates and deposits on the open section, keeping the aluminum parts original. Then it is that type, central part, is changed. So that is how integrated circuits are fabricated. They put a mask, vapor is put in the oven, the metal vapor is put in the oven. I am simplifying it. It's not that simple, of course. That those atoms are deposited onto silicon. They change the mask, do it again, second run, third run, so they can manipulate the silicon by creating lines, rods, and conductors, etc. It becomes an integrated circuit or transistor. So this is P and N. Typical view of the chip is like this. So we have at least hundreds of thousands of transistors on a chip. The first one in 1974 was 4,000 transistors. It had 4,000 transistors. That was Motorola 6800, and it was running at 1 megahertz. It wasn't first. It was one of the successful, I think it's the most successful microchips of all times. It was running at 1 megahertz, 8-bit data and 16-bit address. It had 72 instructions and 4,000 transistors. Cars used this. Most equipment used this. There were computers, so embedded systems, elevators, industrial machines, factories. Many devices are utilized that. And successors are 68,000 or 6502. 6502 is, for example, used in Commodore 64. Some of you may Commodore 64 home computer in 1980s. Okay, let's give a break and about 10 minutes and come back. And at the same time, can you also open the back windows? All of them.
Bir şey sorsam olur mu? Ben hala bilgisayar yapıyorum. MacBook'u mantıklı mı sizce?
Al.
MacBook'un işimi görür mü?
Tabii.
Peki çipi önemli mi? Senin Pro değil mi?
Pro benim de fark etmez. Hafızası 16'ya 512 olsun. Çip önemli değil. Ucuzunu al yani.
Hocam bize önerdiğiniz Arduino'nun başlangıç kitiydi değil mi?
Bayağı başka. Sadece şey de alabilirsin. Düz Arduino da alabilirsin. Çünkü diğerlerini de ayrıca alabilirsin sonra.
Yazıcı oğlu
Gerek-
pasajı demiştiniz.
Ha?
Yazıcı oğlu pasajı.
Yazıcı ondan bir Arduino alabilirsiniz. Klon mu der? Klon da olabilir. Orijinal olmasına gerek yok.
Ya bunun şeyini yapsak da bir grup yapsak da beraber toplu halde alsak
Beraber
belki
gidin.
bir,
Beraber gidin, gezin, dolaşın.
belki bir indirim yapma şansımız olur.
Yok ya, indirim yapmazlar, ne inecek?
Daha önce
50 lira, zaten 250 lira. 50 lira ise 200 lira.
Çok indirim yapmaz yani.
Bir dürüm parası yani.
yok.
Hocam illa Ubuntu kullanmamız lazım. Başka distribütör olur.
Mesela.
Yani Endeavor olsun diyelim ya da Arch.
Yani support'u daha düşük diye. Bence Ubuntu kullansan iyi olur. Sonra bir şey gelecek, şu olmuyor hocam, nasıl yapacağız diyeceksin. Ama kullan. Silersin, öbürünü yüklersin sonra.
Ben dual boot dedim. Alamam.
Ben VirtualBox'ı bile çalıştıramadım. Ben bu şeyi nasıl kuracağım ki ya Ubuntu'yu bilgisayarıma?
İnternetten nasıl kuracağını aramayı biliyor musun?
Denedim ama onları anlamadım ki.
İngilizce arıyor musun? İngilizce ara, Türkçe arama.
Hocam
İngilizce
sen
aradım
bizim
sana.
işini kullanacağız mı biliyor musun?
Ne?
Bizim işini kullanacağız mı bu
Evet.
sene? Kullanacağız. Başka kullanacağımız çok fazla var mı? İlerledikçe mi görürüz sistemde?
Bilmiyorum nereye geleceğiz. Çünkü konular değişti. Yapay zeka ile yapacağız bazı şeyleri. Bilmiyorum yani.
Tamam. Teşekkür ederim.
Ben dersi ilk defa alıyorum da geçen haftaki assignment'ı kaçırdım o yüzden. Bunu bir şekilde telafi etme
Yok.
şansım var mı? Onun puanı gitti
Evet.
benden. Tamam hocam.
Hocam şimdi PDF olarak istiyorsunuz ya assignment'ları. Bu belli bir format kullanmamız gerekiyor mu?
Yok.
Text'e falan yoksa direkt Word'de yazıp çevirsek sorun olur mu?
Genelde Word'de yani
Bazen sıkıntı çıkarabiliyor.
yani
evet, format
açıklama ödevi ise çıkmaz, bir şey olmaz.
olarak. Tamam.
Süslemediğin sürece çıkmaz.
Hocam labda VSL kullansak olur mu?
Ne?
VSL kullansak.
VSL ne?
Windows'ta Linux servisi
Hayır, olmaz.
olmaz mı? Olabilir mi?
Mış gibi yapmayacaksınız. Hayır, olur mu öyle şey?
Ya sanki daha stabil gibi geldi bana
Ne?
da. VirtualBox'tan daha
Hayır, VirtualBox da istemiyorum. Direkt kurun. VirtualBox olur mu ya? Windows'u bırakın yani. Direkt bırakın.
ya bende dual boot var zaten.
Yani dual boot olsun da boot etmeyin oradan. Mecbur kalırsanız.
Merhaba. Daha önce mailleşmiştik benden sonra bilgisayar topluluğu başkanı. Bu hafta sonu etkinlik. Dün bir mail attım ama gördüm.
Geldi. Geleceğim.
Hatırlatmak istedim.
Kaçta geleyim?
Pazar günü 2'de orada olmanız yeterli ama hani incelemek
Tamam.
isterseniz ekipleri cumartesi de gelirsiniz.
Kaç kişi başvurdu? Kaç takım başvurdu? Geçen sene kadar oldu mu?
40 civarı şu an ama artıyor. Yani geçen sene 35 gibi bir şeydi. Yani tabii tamamen katılır mı bilmiyorum ama. Bir de son günlerde artma da genelde
İkram
artıyor.
ayarlandı mı bu sene? Geçen sene orada biraz sıkıntıydı.
Yok.
Popcorn makinesini falan istesek.
Olabilir yani verirlerse olabilir.
Sizin bütçeniz var mı?
Yok, yani Nescafe var sadece.
Nescafe var orada. Çay. Çay
Onlar
ocağı.
SKS'den halledeceğiz,
SKS
evet.
verecek.
Yani şey çay kazanından bahsediyoruz değil mi? Hı hı.
Arada bir şey dağıtacak bir şey lazım ya.
Ya şey yaptık, yine ücret konusunda bir şey yapamadık ama hani kolaylık olsun açısından birkaç yerle konuştuk. Yani biraz indirim yaptılar. Kendimiz onları ayarladık. Hani sadece sayı toplayacağız, onu hani çok bölmemek açısından. Onu yapabildik sadece. Başka konuda da yani Yusuf Hoca ile falan da konuştuk. Defalarca bir şey
Uyku
olmadı.
tulumunuzu getirin falan dediniz mi?
Yok hocam. Gece gözlem etkinliği yapacağız. Daha önce bahsetmiş miydim?
Hava gözlem.
Hatırlamıyorum. Hı hı. Kozmos'ta.
Burada ne gözleyeceksiniz ki burada? Hiçbir şey görünmez.
Hocam gözlüyorlar ya.
Işık var. Işık var.
Ay falan gözleyebiliriz o gece dediler, bilmiyorum.
Çayırova'da bir şey gözleyemezsin. Otoban ışıkları var, ne var. Çok az görürsün.
Bilmiyorum. Yani gece onu yapacağız. Akışta o var. Onun dışında çalışmak isteyen çalışmaya devam edecek.
Çadır işi yok.
Hocam çadırlık bir şey yok ya.
Gece burada kalıyorlar ya.
Yani çalışmaya devam ediliyor ama ya genelde. Zaten yarışma süresi hani tam 48'de tamamlanmadığı için mecbur çalışıyorlar gibi bir şey oluyor. Ya geçen sene
Sağda
varmış
solda
en
uyuyacak
son.
yerleri yoktu ya. Yerlerde taştı.
Kongre şeylerinden birini de ayırttım ben.
Odanın bir tanesini ayırdınız.
Ne olur ne olmaz
Aşağıdaki
bulunsun
odalardan
diye.
birini.
Aşağısı komple bizim. Bir de ben kırmızı salondu sanırım en küçüğü, onu da ayırttım. Zaten
Oraya
hafta
işte
sonu binada başka kimse olmaz.
Uyku matı falan getirseler, uyku tulumu getirseler uyurlar. Ama çok da uyumaları anlamsız olur.
Ya evet.
İyi
Ki
tamam.
yani isteyen getirir zaten.
İstemem, tamam.
Ama sanmıyorum yani. Bana soranlara genelde öyle bir ortam olmuyor yani. Öyle bir şey isteyen
Bir
olmuyor.
günde
gibi.
olmuyor. Tamam,
Evet.
tamam iyi. Tamam.
Hocam ben şey soracaktım. Ben de sanal makine yüklerken sıkıntı çıktı VirtualBox'ta. VMware yükledim. Lab için bir sıkıntısı olur mu?
VMware mi yükledin?
Hı hı.
Ya onlar illa yani niye Windows kullanıyorsunuz ki? Allah'ın emri diye mi?
Ben Ubuntu kurmuştum zaten, Ubuntu kuruldu.
Yani bence Ubuntu'yu kurun ya. Hep bir
VSL
şey.
üzerinden kullanıyorum.
Çok
ama
acil değil ama
diye
kurun yani.
düşünüyorum.
Ha?
VSL kullanıyorum. Görüyorum.
VSL,
Termin.
Windows'daki VSL. Ya o da saçma.
Tam direkt Ubuntu'ya geçelim biz.
Çünkü yavaş yavaş onu benimsemeniz lazım. Başka programları indirmeniz lazım. Utility'si, şusu busu. Mesela şeyi şimdi ona öğretmeye çalışacağım ben. VS Code'la beraber yapay zeka Copilot'u yükleyip orada çalışmanızı isteyeceğim. Şimdi direktörü sistemini görecek, terminali görecek. Diyeceksiniz ki benimkinde görmüyor, bilmem ne olmuyor. Yapmayın yani. Ha. Sadece ders için değil yani. Çünkü piyasada da millet tamamen bırakmış Windows'u. Bütün developer arkadaşlar, çalışanlar Mac kullanıyor. Mac kullanamayanlar da Ubuntu kullanıyor. Ne haber?
Evet hocam, ben şey soracaktım. Ödeviniz zaten teslim ettim de çok telefondan hazırladım. Ne kadar iyi oldu. Bu ödevlerin tam olarak şey, mesela burada çok anlayamadım. Neye göre değerlendiriyorsunuz? Mesela uzun mu olmalıydı, kısa mı olmalıydı? Şeyi çözemedim.
Doğru olmasına göre.
Ya da mesela kopyala yapıştır yapmak istemediğim için bütün cümleleri değiştirdim.
İyi.
Hani şeyi, ödevin değerlendirme sistemini sormak.
Doğru olmasına göre değerlendireceğiz. Kopya var mı bakacağız. Tam emin değiliz daha nasıl değerlendireceğimizi ama yapay zeka ile değerlendirmeye çalışacağız. Yapay zeka ile detaylı değerlendirmeye çalışacağız. Dolayısıyla işte kopyası bilmem nesi vesairesi nereyle gideriz bilmiyorum ama sizi üzecek bir şekilde olmayacak. Yani ödevler sizin için.
Hayır şey.
Biz ödevleri bir yerde kullanmayacağız yani.
İşte bu ödev sayılıyor.
Ha?
Bu ödev nota dahil.
Dahil.
Sağ olun.
Bugün quizimiz olacak. Hayır sonra. Çıkıştan önce. Yani ders sonunda. Okay, so let's review the logic gate symbols: OR, NOR, AND, NAND, XOR, XNOR, nothing, which is buffer. One of your friends asked in the last lecture, and not. Usually, when you see a circle, it means not. Teşekkürler. So usually we have circles in order to indicate not. Okay. So thinking about gate, we can make an analogy of transistor or gate to a faucet or a water valve. We can turn it off, we can turn it on. So if we have such a device, we can make great things. This is what we have. That's gate, source, and sink. Gate, source, and sink. This is sink. Sink. In some books, we have drain. Drain is also has the same meaning, like sink. Okay. So by controlling voltage here, I can make this conductor or no conductor. I can turn it on, off. If it is transistor, kapıyı kapattınız mı? I can change the level of conductivity. Little bit conductor, more conductor, more conductor, more conductor, more conductor. So it will be slowly changing. With the field effect transistor, with the MOS, here we have a current. Here we don't have a current. We only have voltage. The voltage affects the conductivity. And usually the logic circuits are metal oxide semiconductor, MOS. Metal is probably aluminum, as I said. Metal oxide semiconductor. So there is no current flowing from here to here. In transistor, it flows. Generally, they are transistors, but metal oxide transistors, field effect transistors, FET, they don't have current flowing from the base, from the gate. We call them gate. So it is only voltage, which is kind of better for logic circuits because current means more heat, more energy dissipation. So opening and closing using voltages without current is kind of easier on the circuit when you have large number of digital operations. For the analog operation, for example, when you are making an amplifier, stereo amplifier, then transistor is good because you need to play with the waveforms in analog. You don't have to turn on and off. You have to proportionally increase and decrease the loudspeaker movement. Loudspeaker movement is controlled up and down. It is not this or that. It is in between. Therefore, transistor is better. But for the digital circuit, whether it is this way or that way, on-off operation is better. So FET is used. Metal oxide semiconductor is a type of field effect transistor, and when you use them in couple without resistor, it means complementary metal oxide semiconductor. Instead of using one transistor and 5 volts, no, 5 volt at the top and 1 kilo ohm resistor. So there will be a dissipation in this 1 kilo ohm resistor, and you have 5 volts here. 5 volts, right? So this is the input voltage. So you can, this is ground. When this is conducting, this is connected to the ground. So what is the output voltage if the input is 1? Output is 0, right? Because it is connected. But there is current flowing, like say 1 milliamps, 5 volts, 1K, 5 volts, 1K, how much milliamps? 5 milliamps. 5 milliamperes goes through. So there is a dissipation. Power dissipation, right? The logic works, but power dissipation. This is an inverting gate, not gate. If you give 0 from here, 0 volts, then this becomes open. So this output becomes, this is output. This output becomes 5 volts because there is no current flowing. And this is open circuit. Do you understand? If you don't understand, let me know. Sessizlik iyi işaret değil.
Bir kez daha.
So this is a transistor. I dropped it again, same thing. If I give 5 volts from here, this transistor starts conducting. It becomes semiconductor to conductor. So it is connected. So what will be the output voltage? Yeah, 0 volt. Because this is connected. Up and down is connected, right? It is connected. If I give 0 volt instead of 5, it will be disconnected. If it is disconnected, what will be the output voltage? 5 volts. Because there is no current flowing, it is connected to the 5 volts by 1 kilo ohm resistor. But the condition is when I am providing 5 volts, it is connected, and how much current goes through? 5 milliamps, right? 5 milliamps on 1K. Output will be 0. So 5 milliamps and 5 volts. How much power? 25 milliwatt. 25 milliwatt for one transistor. It's too much. It's okay for it's an amplifier because the transistors you will be using like 5 or 6 or 10 in a radio, for example. But in an integrated circuit, this is unacceptable. Too much power. And heat, of course. Power is equal to heat. So what are we going to do? So the question is, can we replace this resistor with something else so that when I give 5, there is also no current? The answer is yes. The answer is CMOS. In the CMOS circuit, the working is like this. When I provide 5 volts, okay, since this is P type, this is N type. This is PMOS. This is NMOS. One PMOS and one NMOS means complementary CMOS. So the upper one is PNP, lower one is NPN. So upper one works if I pull, lower one works if I push. Okay? So if I pull it down, it works. It is connected. If I hold it up, this is disconnected. This one, if I hold it up, it is connected. If I pull it down, it is disconnected. Okay? So combined with 2, if I give 5 volts, this becomes open, this becomes closed. So output becomes 0. No current because this is open. If I give 0 volts, this becomes connected, this becomes disconnected. No current, but output is 5 volts. So without spending any current, except charge transfers, without spending any current, I can open and close a gate. So this is what I call CMOS. And this is CMOS NOT gate. The symbol is this. Okay? So without resistor. This was with the resistor. It consumes power. Okay. So NAND. I said NAND is easier to make than AND because of this reason, because there is an inversion going on. In order to make AND, I have to put this one here. Then it becomes AND. So NAND not becomes AND. So if I give 5 volts from here, this becomes open. This becomes open. So output will be 0. So any of them is 1, no current flows. But if both of them are 0, output will be 1. So if this is 0 and this is 0, if this is 0, this conducts. If this is 0, this also conducts. If this is 0, this doesn't conduct. This doesn't conduct. So output will be the battery voltage. Output will be 5 volt. Otherwise, it is 0. So that means X, Y, Z. 0, 0, 0, 1, 1, 0, 1, 0, 1, 1. 1 means 5 volts, right? So 0, 0, 0, 0, 1, 0, 0, 0, 1, 0, 0, 1, 1, 1. But this is AND. 1, 0, 0, 0. Am I correct? I think if one of them is 0, it is connected. So if one of them is 0, it is also 1. 1, 1, 1, 0. Okay. So, and not. Any questions? In order to make it regular and put an inverter in front of it, then it becomes AND. Let's make it correct this time. X, Y, Z. 1, no, 0, 0, 0, 1, 1, 0, 1, 1. This will be the output. NOR. In the NOR, zero, zero, zero, 1, 1, 0, 1, 1. So 0, no, 0, 1, 1, 1. If this is 0, then this conducts. If this is also 0, this conducts. If the this one, right? Yeah, because it is NOR. Sorry. Yeah. This is 1. Otherwise 0. If both of them are 0, this is connected, so it is 5 volts. If any of them is 1, it is disconnected. Therefore, if any of them is 1, output is 0. This is what NOR gate is. So, another figure from another book, yeah.
In the coupled MOS, does the second, the one without the dot, does it take the voltage back out of the system?
Current means, you mean current? No.
The energy, I don't know.
Yeah, no current is flowing. Think about is like
No, there is some voltage, there is the presence of
the voltage is the voltage is provided by input.
Yes.
So if
But
the
output shouldn't also be voltage.
yes, it is coming from the battery.
So the circuits on the top is loading the system with current, and the one on the bottom is taking back out. Is what I understand.
It is like this. If you give 5 volts, this I is equal to 0 all the time. No current. But if you give 5 volts, and this is 5 volts, or 10, whatever, this becomes conductor. If you don't give 5 volts, this becomes isolator. So the only current flows from 5 volts to downwards. There is a current. Okay? No current from the input.